So let's talk about the different types of packets EIGRP uses. So most packets are sent to the multicast address of 224.0010. Yes, you will want to memorize that address for the exam, 224.0010. So EIGRP has packets called hello packets, which, like it says, is used to build brand new neighbor relationships and maintain neighbor relationships. So you're not going to send me any of your routes until you and I exchange some hello packets. And within those hello packets, there's some parameters that need to match before we can become neighbors. And then once we're neighbors, then we can exchange routes. After that point in time, we will continue to exchange hellos periodically just to make sure that we're still alive, that we're still friends. The other type of packets that EIGRP can utilize are updates. That's the name of the packet that actually carries a routing update about new routes or changed routes or routes that have gone down. And initially that's unicast. So when you and I first form a neighbor relationship, I'm going to send you all my routes directly to you, to your IP address. From that point on, the other updates I send you in the future about new things I learn or change things will go to that multicast address of 224.0010. Acknowledgements. Actually, a lot of people mistakenly believe that there's actually a unique type of EIGRP packet called an EIGRP acknowledgement, and that's not the case. In the packets that we see down below, the updates, the queries, and the replies, not the acknowledgements, the updates, the queries, and replies, those are called EIGRP reliable packets. And this bears mentioning. So if we refer back to RIP, if I'm looking at an IP packet that's carrying a RIP update, you've got your layer 2 header, which might be Ethernet or something. You've got your IP header. Then you've got a UDP header, and then RIP. So RIP is actually carried by UDP and then by IP. With EIGRP and OSPF, they both reside directly behind the IP header. So EIGRP and OSPF do not use TCP or UDP. They are their own separate IP protocol right behind the IP header. Now, both OSPF and EIGRP, one thing they have in common is that some of their packets, when they send those packets, the neighbor has to acknowledge getting them. And if the neighbor doesn't acknowledge getting them, they will be resent. Sort of like TCP does at layer 4, except they have their own mechanisms built in to do that. So think about how TCP does it, right? At layer 4, at the transport layer. When TCP creates a TCP segment, it puts a sequence number in there, and then it sends it out. And it says, okay, my person I'm talking to, whoever they are, is going to have to send me a TCP acknowledgement acknowledging that segment that I just sent. Otherwise, I'm going to resend it. Well, the same thing is true in EIGRP. For these packets that must be reliable, that must get acknowledgements, which are updates, queries, and replies, and yep, you'll want to know that, those packets are all given sequence numbers. So if I send you, for example, an EIGRP update with a sequence number, you're going to acknowledge that sequence number back to me. But here's how you're going to do it. In the EIGRP hello packet, there's a field for sequence number. Now, if you and I are just exchanging hello packets and nothing else is going on, that sequence number field in the hello packet will just be zeroed out because we're not really acknowledging anything. We're just sending hellos. But if I send you an update packet, the next hello packet you send to me will actually have the sequence number inside of it of that update that I just sent you. So that is your way of acknowledging what you just received from me. So that's why I wanted to make that clear, is that there's not any formal EIGRP acknowledgement packet. An EIGRP acknowledgement is a mechanism within an EIGRP hello. EIGRP queries. So this is also something that's kind of unique between EIGRP and other routing protocols. If I was, let's say, running RIP or running OSPF, and I had learned about the 70.70 network from some router back there, if all of a sudden that router back there poisoned that route said that route's no longer good, you can't get to it from me. If I was running RIP or OSPF, I would simply strip it out of my routing table, forget about it, and that's it. That's not what EIGRP does. So let's assume for a minute that I'm a router and I have an EIGRP neighbor relationship with someone right there. He and I are neighbors. I'm also neighbors with you. Now this guy right here has sent me an EIGRP update for the 70 network. So I'm using him to get there. If that neighbor suddenly sends me an update saying I'm poisoning that route, it's no longer reachable through me, what I will actually do is I'll say, well, I've got this other neighbor right here. Maybe he can get to that route. So I'll actually send you a special type of a packet called an EIGRP query, where I say, hey, any chance I could use you to get to that network? And then you will send me back a reply, which either says, yes, Keith, you can use me, or nope, sorry, you can't use me. So the query and the reply is an additional mechanism of EIGRP so that before we finally get rid of a route, let's just query our neighbors just to see if maybe they know of an alternative way to get there before we give up on it. The last thing I want to talk about in this section are categories of routes. And this relates to administrative distance. So at the ICMD 1 level, you learned that Cisco routers rank and sort the methods or ways that they can learn of routes on these numbers based on administrative distance. The lower the administrative distance, the more preferable that method is. For example, what is the administrative distance of a directly connected route? That was 0. What was the next higher one on the list of administrative distance? Static routes. And static routes have an administrative distance of 1. And then all my dynamic routing protocols went up from that. So another thing that makes EIGRP different from RIP or OSPF is that it actually has 2 different values for administrative distance, a lower one and then a much higher one. And depending on how the route was injected into EIGRP, so the router that's actually advertising that route via EIGRP, there's actually 2 ways it could do that. And depending on which method it chooses will determine for all the other routers that receive that route what administrative distance value they assign to it. Because remember, administrative distance is not something that's actually carried inside of a packet. I'm not going to send you a packet saying, here's an update and the administrative distance is 90 or the administrative distance is 170. It's up to you. Every router independently assigns an administrative distance value to all these different things. So you could actually go into one router and say, okay, even though RIP is really high up on the list with an administrative distance of 120 and OSPF and EIGRP are more preferred over that, I want to change the administrative distance of RIP to maybe 5. So it's actually the most preferred routing protocol. So you could do that in one router and it would not affect the other routers around it. So administrative distance is what we call a locally significant value. So how does EIGRP deal with this? EIGRP classifies routes that were originated with the network command as EIGRP internal routes. So if you've done any studying on RIP before you got to this section, which hopefully you have, and if you haven't studied RIP, I'd recommend that at this point you stop this video and you go back to some videos on RIP. RIP is the easiest routing protocol to get your feet wet and to start learning about, and then come back to this. But if you have learned about RIP, you learned that with RIP, you typed router RIP at the global configuration level, and then to actually activate it on your interfaces, you would type network, and then whatever the network was on your interfaces. And that would turn on RIP, and that would also give RIP permission to advertise those networks that it is actually connected to. EIGRP is pretty much exactly the same. You're going to type the network command under EIGRP. That's going to activate it on your various interfaces, and that's going to give EIGRP permission to advertise those directly connected networks. Now when it does, when it sends that network in an update, there's a little flag in there that says, this is an EIGRP internal network. So when you receive an EIGRP update from me, you and I are neighbors, and you see that little flag in there saying it's an EIGRP internal network, you will assign it an administrative distance of 90 that you see right here. Well, what's the other way that EIGRP could advertise networks? Well, let's say I'm a router and I'm running EIGRP with you and I'm running RIP with this other guy. So I'm sitting right in the middle of two different routing domains. Well, if I want you to have reachability to those routes over there that I learned via RIP, I have to take my RIP routes and somehow convert them, change them into something that you understand, EIGRP. That process is called redistribution. So redistribution is when you tell a routing protocol, go into the routing table, find something there that you wouldn't normally understand, convert it into your language, and then send it to your neighbors. That's called redistribution. At the CCNA level, you're not expected to know how to do redistribution, but they do want you to know what that term means. So in EIGRP, when EIGRP does that, when it redistributes a route and then sends it out, it sets another bit, another flag saying this is an EIGRP external route. Those routes have a much higher administrative distance. If you get that one, you will assign that one an administrative distance of 170. So clearly, you can see that if one router sends you, let's say, the 20 network as an EIGRP internal route, and let's say, well, all right, let's do it like this. Actually, I think this really will demonstrate it quite well. So let's say as an example that here is a router. I'll make this a little larger for you. We'll just say router A, here is router B, and here is router C. Okay, router B says, let me tell you about the 3 network, and the distance is equal to 7, and this is an EIGRP external route, meaning that some router somewhere used the redistribution feature to get that into EIGRP. And then router C sends that exact same route. This time the distance is much, much worse. The distance is 8,000, but it's an EIGRP internal route. Well, guess what? Router A is going to prefer the blue route because administrative distance is always the first thing that's used as a tiebreaker. Only if the administrative distance value is the same do we then look at the metric. So in this particular case, router A will say, oh, well, this blue update, I'm going to give an administrative distance of 90. The one in red, I'm given an administrative distance of 170. So this is the best. Regardless of the fact that its distance is just horrible and it's going to take me a lot longer to get there, I'm going to prefer my EIGRP internal over my EIGRP external route.